In this video, I'm just going to have a look at the 2016 higher level question C1. Okay, so this is the map that you will be given here in relation to a swimming pool here. So we'll just have a look at the question here first of all, and we'll go through it then. Okay, so question C1, the accompanied map located on the back page of section A shows the plan of a garden with a swimming pool similar to that in the image on the right. The ground contours are at 1 metre vertical intervals. On the map, ABCD is the edge of the pool and is level at an altitude of 5 metres. So straight away, it's a slightly different question than previous questions or even questions since, in terms of it's not to do with roads, but it's the exact same principles we use here. And also it uses 1 metre vertical intervals instead of we may be used to 5 metre and 10 metre vertical intervals. So that might throw a few people, or that could have thrown a few people in this question in the exam. Also, it uses a scale of 1:100, but we'll see that will become a bit clearer with the 1 metre vertical intervals. It's quite straightforward as well. So you're told using side slopes of 1 and 1 for both cuttings and embankments, show the earthworks necessary to accommodate the eastern edge of the pool. Okay, so note the earthworks between A and B have already been completed for you. So if we go back to our map here, we've been asked to complete earthworks on the eastern side of the pool. So this is the pool here, and we've been asked to complete, we've already been told that A and B is complete first, obviously here. So we've complete from B to C to D here, this part of the eastern side of the pool of the earthworks necessary. Okay, so the first thing we're going to have a look at is the scale first of all, and you should always kind of write a few thumbnail sketches and notes here to before you start to, that you're sure of your scale and you're sure of your side slopes for both your cuttings and your embankments. So the scale first of all you can see here is 1:100. So that basically means 1 millimetre on the map is equal to 100 millimetres in reality. Okay, so if we translate that, then we're in 1 metre vertical intervals here. So each one of these lines represents a 1 metre vertical interval change in the map. So that means for every 10 millimetres on the map is equal to 1,000 millimetres in reality. So basically then 10 millimetres therefore is equal to 1 metre on the map. Okay, so for every 10 millimetres on the page it's equal to 1 metre on the map in terms of the vertical interval. So you're told we're using side slopes of 1 and 1 for both cuttings and embankments. So if we have a 1 in 1, so if we draw out our little triangle for our cuttings and our embankments, they're both the same here, so we're just going to do it once. So that means for every 1 metre we go out is a 1 metre difference in change in altitude. So it's 1 metre change in altitude. Okay, so 1 metre on the map is going to be 10 millimetres. Okay, so for every 10 millimetres, we've already said that for every 10 millimetres it's equal to 1 metre on the map. So if I start here, I'm going to do the section between D and C here first of all here. Okay, so I'm going to measure out because it's level. First of all, you need to come along and write in your measurements at each point on the map. It's always a good idea to mark out your measurements, your altitudes at each point. It gives you a clear idea. So if we see here from between D and C, we can see that the ground, this edge here is all at 5 metres. So it's level here between D and C at 5 metres in altitude. If we come out from that, then we can see here, there's a 5 metre line, there's a 5 metre line there. Coming out from that, we're going to 6 metres, 7 metres, 8 metres, 9 metres, and so on. So that means that this ground is getting sloping. It's higher coming out from the side of the swimming pool here. So we're going to have to use a cutting here. We're going to be cutting into the embankment here, or we're going to be cutting into the slope here of the ground here. So it's going to be a cutting that we're using here. It wouldn't make any difference in this case anyway, because you're using side slopes of 1 and 1 for both cuttings and embankments. So you don't have to worry too much in this question, but just for other questions. So first thing I'm going to do here is I'm going to measure out 10 millimetres here for my different heights here for my cutting here. Okay, so each line now will be parallel with the edge of the swimming pool here. So each one of these contour lines now is showing a difference in altitude of 1 metre every time. Okay, so I started here at the pool because this is a cutting here. It's going to be increasing as they're going out from the pool here. So I started there at the edge of pool at 5 metres. So as I work out here now, then our lines will be increasing here. So this line here will be our 6 metre line, 7 metre, 8 metre and 9 metre. Okay, so each time I went out, I only need to go as far as 9 metres because that's the maximum altitude that I have there. Okay, so once I have that done, then it's just a matter of picking out my points for my embankment. I'm at 5 metres here, so I'm working out, this is my 6 metre line here on where across the 6 metre contour line. So I'll be crossing there, obviously that's 1 point, 7 metre, 8 metre and 9 metre there and 9 metre there. Again, back to my 8 metre line, 7 and 6 again, and that joins back to 5 there again. Okay, so then carefully we can just draw that in. Be careful to curve between your points. So just go over nice and carefully. First of all, you can use your flexi curve if you like for this. There's no great need to if you're nice and careful and just take your time sketching it in. Make sure you're curving between your points as you go along to create your contour. Okay, and once we're happy with that, then we just go over it in one nice smooth like so. Okay, so that's our first part done there. Okay, that is our cutting there. So obviously for our cutting we will put in our balloons at the end. We'll put in our balloons to mark that out there. Okay, so we're going to move on from B to C. Again, is level at 5 metres, B and C is at 5 metres. The only difference is this is our curve section. We have the start of the curve here, end of the curve there. Okay, so what I'm going to do here is I'm just going to first of all extend on this line a little bit here. Okay, just to mark out where I'm starting and finishing. Now, I'm using the exact same intervals here because it's 1 and 1 for both cutting and embankments. I'm going to use the same intervals here, guys. Okay, so we have the center of our curve here, and we're just going to extend out to our points here as before. Okay, now the difference in this time is if you look at the ground contours that's coming out from this curved part here, you'll see that the ground falls away from the actual edge of the pool. So if you look here, so we're at 5 metres here, then we're at 4, 3, 2. We'll go down to 2 metres is the lowest, back up to 3, 4 and back to 5 again. So all this ground from here to here is falling away from the edge of the pool because the pool is at 5 metres here. So this will be an embankment now this time. Okay, so instead of going from 5 to 6 to 7 to 8 to 9, we are now going in the opposite direction. So I'm just going to mark these up here, and I'm going to mark in the heights of these lines here again. So as we move out for an embankment, as we move out, our heights will be reduced this time. So we're at 5 metres here. This line here will be our 4 metre line, 3 and 2 metre line, and we don't need to actually go any further than our 2 metres, even though I've drawn it in there, because it doesn't actually go down to 1 metre. Okay, so we have our 3 lines there. So if we look at this here again, just pick out our points again. We're at 5 metres. This is our 4 metre line on our 4 metre line here. Again, just check it as you go. 3 metres, 2 and 2 again, and back to our 3 metre line. This is why it's important to have the marked in, because it can get confusing as you go along. 4 metres, and it's easy to make a simple mistake as in picking the wrong point on the line. So that's our contour there. Again, nice and carefully, we can just draw it in. Curve between your points. Back in. Okay, and just go over it in nice, as neatly as you can. I would encourage you when you're doing this to draw in your lines the full length along as I've done there. So nice and lightly draw them in the full length along, and I would encourage you to mark out your drawings as I've done there. So it just, both for yourself in the exam, you won't make a mistake, and when it comes to correcting as well, if we've just short little dots here, it's clear to the examiner that you know what you're doing, and it shows a good understanding by doing it that way. If we just use short little lines here and there, and I know some people have been doing that, is you just using a short line there, which is fine, but I would encourage you just to use straight lines along like that there, okay? So that's the first part A of the question done there, okay? So that's part A. So we have that much done, okay? So we're going to move on now to part B, okay? So part B, the next part of this question here, it's looking at DE is the edge of a sloping pathway. At D, the pathway is at an altitude of 5 metres and it falls uniformly to an altitude of 4 metres at E. Using side slopes as above, so the same side slopes that we used above, show the earthworks, the cuttings, so it's actually telling you that it's a cutting necessary to accommodate the northern edge of the pathway. Okay, so we'll come back to our question here now, okay, and we'll have a look at the pathway here itself, okay. So you can see here, again, mark out your heights first of all, okay. So we're just worried about, forget about everything else, we're just worried about this pathway for now. So D is at 5 metres, E is at 4 metres there. So what we're going to look at first of all is, you know that it's fallen uniformly between D and E. It fell by 1 metre there, okay. Now you can see that the ground around it here, we're at 5 metres here, okay, 5, 6, 7. So again, the ground is sloping up as away from it, okay. So it's going to be, you're already told in the question, it's going to be a cutting. Because the ground is higher than the road itself or than the pathway itself, it's going to be a cutting. What you need to realise for a cutting is the cut cone always goes at the lowest part of the road. The cut cone always goes at the lowest part of the road. The fill cone always goes at the highest part of the road, okay? So what we're going to have a look at here is where we're going to position our cone. So we've already said that our cut cone is going to go at the lowest part of the road there. So the next thing we need to look at is what size is our cut cone going to be. So we know we've dropped from D to E by 1 metre. So basically our cone is going to have to be a 1 metre radius cone. Because we've dropped by 1 metre, our cuttings is a 1 in 1 for our side slopes. So our cone is going to have to be the equivalent to the drop here in altitude. So it's a 1 metre drop. That means it's going to be a 1 metre radius on our cone. And if we scale that down to the size, to our scale for our map here, that means it's going to be 10 millimetres overall, okay? So we're going to use a 10 millimetre radius cone here. I'm going to use a 10 millimetre radius cone there, okay? So once we have that drawn in there, guys, okay, we have a 10 millimetre radius cone. That is an inverted cone at that point. Because at the lowest point of the road, our cut cone is an inverted cone. What we're going to do then is we're going to join that with a tangent back to point D there. And that line, okay, I'll just put in a little bit heavier so you can see it on the video here. That line now is level with the altitude of the road. So that line there is a 5 metre altitude, okay? And because this is a cut cone and it's an inverted cone, as we move away from the cone, we're going to be increasing in altitude, okay? As we move away from the cone, we're going to be increasing in altitude. So again, we're going to use 10 millimetre intervals as we go out here because 1 in 1 and it's 1 metre vertical intervals, and we scale that to the page, it'll be 10 metre vertical intervals. What I'm going to do here, guys, is I'm just going to draw a line out just to be accurate that's perpendicular with that line there, and I'm going to measure out my distances in my contours on that there, okay? So I know it's going to be 10 millimetre contours as we go out from it, so I'm just going to measure out 10 millimetres each time on that there, okay? So I'm going to go out to that there, okay? So each time you can use your sliding set squares for this. It'll probably be as quick and as handy as any. You can also use your adjustable set square, but if it's just a small part of it like this, your sliding set squares probably are as quick and handy as any here, okay? So each time I move out here, we're going up by a metre, okay, and we'll mark that out on our drawing, okay. So I've moved out there, so each one of them lines, if I mark them out here, so I'm at 5 meters here, so this will be 6 meters, 7 meters, and so on. Okay, so every time I move out there, I'm moving up by a meter. Okay, so all I have to do now is start to pick out my points here then on that. Okay, so I'm at 5 meters here, so I'll be starting here at my 5 meter line here. Okay, point E is at 4 meters here. Okay, so point E, so this edge along the road here is at 4 meters here. Okay, so what I will also have to do is I will have to bring one line this down this way as well by 10 millimeters. Okay, so you need to draw that down as well by 10 millimeters just to be accurate to finish your drawing as well. Okay, so I'm going to bring one, because we have to go from 4 meters up, we're going to go line this side, and that will be at 4 meters. So I have my contour set up there now. Okay, you can see I'm at 4 meters there, and right at that point, because I've correctly set this up, my 4 meter line exactly passes through 4 meters at that point there. So at E there, I'm exactly passing 4 meters with that line that I've just drawn there. So it just shows that I have it set up correctly. Okay, so what I'm going to start there, so I'm at 4 meters there. As I work my way out now, I'll be going up from 5 meters and so on there. Okay, so I'm at my 4 meters. We don't the line doesn't touch it there. Okay, so we're at our 4 meter line there. So if we look at our contours as we move out from that, we'll be going up in contour. So we're at 5 here again. If we look here, this will be our 6 there, 7, 8, back down to 8, 7, 6. Okay, and we've gone on that far there to 6. As we will continue on, if obviously it's going off the map here now, if we were to continue on, it will continue on down that way there. Okay, but we're at 6 meters there. We can't go any further because our 5 meter line doesn't actually cross it, so we'll just draw it on there as we go then in the end. Okay, so we just draw in that there. Again, nice and carefully curving between your points. Just take your time on this part here. And we'll be heading off that way then as it progresses on then. Okay, so that is our contours done there on that part of the map there. Okay, so what we're going to have a look at, we'll just set up our balloons on this side here, and we'll just finish that part then. Okay, so this is an embankment here, so obviously if this is an embankment, our balloons are going to be going, if you were standing on this pathway and you let go of the balloon, they would head up the way there. Okay, so we're going to draw in our balloons heading up the way there like that. Okay, so if you were standing on the pathway and let go of the balloon, it would head upwards, so therefore we're just going to draw them in here and they're heading up the way like that. Again, this part here, we can see here, is a cutting here again. So if we look here, if we're at the edge of the pool and we let go of the balloon, this is going to be heading uphill here this way again. Okay, so we're just going to draw in, there's no set amount of these, but just to outline the drawing of where they are. Okay, and again, if we're over here then, this is an embankment, so the lowest part of this is down here. So if you're standing down here and you let go of the balloon, it's going to head up towards the pool there. Okay. And again, if we look at this one here, we'll just finish from A to B. Even though it was done first, we can see here that that is a cutting again, because the ground here is higher than the edge of the pool, so they are going to be heading up in this direction here. Okay, so that's the first part of the question done there, and we should be okay with that then. Okay, so if we're moving on then to part C. Okay, so part C, you're told at the southern end, a floor slab of the pool is sloping and is of uniform thickness. Okay, so the floor slab is sloping and it's of uniform thickness. R and S, so if we look here, R and S are 2 points on the floor and their altitudes are at 4 meters and 3 meters respectively. So the first thing we should be doing here is writing in the altitude of R and the altitude of S, so 4 and 3 meters respectively. A vertical borehole at S, so a vertical borehole is drilled here at S, straight down here at S, okay? Vertical, if it's vertical, straight down, reveals the bottom surface of the pool floor slab at an altitude of 1.5 meters. So basically this is going to be a concrete floor in the bottom of the pool and there's a thickness of it. S is at the top surface of the floor slab. So if we drill straight down through that floor slab, it's going to be, we're going to have to drill down till we get to an altitude of 1.5 meters where it actually drills through the floor slab. So the thickness of the floor slab goes down until it reaches an altitude of 1.5 meters, okay? The strike of the floor is north 55 degrees east as indicated by the line L. So you're already given the strike. So the line L there, so this line here, line L, that is actually the strike. In previous questions you had to find the strike, okay? But this time you're actually given it already. So mark that in as a strike, okay? So what you're asked to do is determine the dip and thickness of the floor slab. So there's nothing new here. You've already done all this stuff. You've just applied it in different ways in previous questions. So if we just come over here to this part of the question here, okay, so you're not doing anything new here than you did before. You're told R is at 4 meters, S is at 3 meters. Both R and S are at the top surface of the swimming pool, okay? You're given a strike line which is on the surface, it's a level line on the surface of the floor slab. You know if you look along any strike line, you will find the dip of the floor slab. If you look along the strike line of any stratum of ore, you'll see that surface as an edge. So the strike line is a true length line on the surface of a stratum or on the surface of a plane. If you look along a true length line, you see that surface as an edge. So if we're looking at this here, we're going to look along this strike line here and we're going to find the thickness and the dip of the floor slab here, okay? So what I'm going to do here is I'm just going to set this up here. I'm going to look along the strike here. I'm going to bring out point R and point S, okay? So I'm going to project out them 2 points there, okay? So what I'm going to also do here now is I'm going to set up my new XY line here and I'm going to set it up reasonably close as I can to point S here, okay? So it's at 90 degrees to my strike line, okay? So I'm going to set it up really close here to point S here and I'm going to call this my X1, Y1 line. So just like previous questions, this is my X1, Y1 line. I'm just taking an auxiliary here, okay? So you know the height of R is 40 meters, okay? So you know the height of R there is 40 meters, or is 4 meters, sorry guys, it's 4 meters altogether. So if it's 4 meters in this, if we scale that down to our scale that we're using on our page, we know that that's going to be 40 millimeters on our page. So we can take point R and we can strike it off here. We know that that's going to be at an altitude of 40 millimeters. That is point R here, okay? That's our point R there, okay? We can do the very same for point S. We know point S is at 3 meters, which is 30 millimeters on our drawing here. So point S here. So that's point S there, okay? So if we join point R and point S, that is the top surface of the floor of that swimming pool there, okay? So what we also know is we have drilled a borehole. You're told in the question that a vertical borehole at S reveals the bottom surface of the floor, the pool's floor slab at an altitude. So that's important there. It's not a distance now. It's an altitude of 1.5 meters. So you know that if we drill straight down through here, this will be the line that our drill bit will take, and it will burst out through the bottom of the floor of the swimming pool at an altitude of 1.5 meters. So an altitude of 1.5 meters, if we scale that to our scale that we're using on our map here, we know that that's going to be 15 millimeters. So we can measure up here 15 millimeters here, and that reveals that point there at an altitude of 1.5 meters. So that from there to there is where it bursts through. So our pool, the bottom surface of our pool and the top surface of our pool are going to be parallel to one another. So if we draw them parallel to one another like this, that now gives us the thickness and the dip of the swimming pool. Okay, so that is the thickness of the slab here. So if we set this up here, and if we just draw in a line between them two there, and mark that in as T, that is our thickness of our swimming pool. Okay, again, the dip of the swimming pool then is the angle it makes to the horizontal plane. So we can just set this up here by drawing this in. We can draw a line out there at an angle like that there. Okay, and that angle from there to there is now, that is the dip of the swimming pool. Okay, so that angle there is the dip of the swimming pool there. Okay, so I'm just going to mark that in as the dip. Okay, and that is our thickness, and that is our the dip of the swimming pool there. Okay, so we have them two done now. We have our dip and our thickness, and that is all we needed for part C. Okay, so our dip and our thickness, that's all we needed for part C. Okay, so if we have a look now, okay, we have most of the question done now at this stage. Okay, so all we need to do now is have a look at the last part, is part D. Okay, so part D, there are 4 entrance steps to the pool as shown. Okay, so you have your 4 entrance steps down here to the pool as shown. The top step is level at an altitude of 4.8 meters. So again, we should be writing this in here. Okay, so we have a top step here from P to Q, so they are both at 4.8 meters. Okay, so they're 4.8 meters. Okay, in the space provided, draw the vertical section or profile through the steps and floor slab along the line PS, showing the steps to be of equal height. That's important there as well, of equal height. Okay, so we basically have to draw in a section through P to S, okay, of what we're going to see, a profile. So we've already done this a good bit now for contour maps in relation to the ground of mountains and slopes and valleys and so on. This time they're asking you to do it through a swimming pool. So it's the exact same principle, we're just doing it through a swimming pool. We know the altitudes of P, we know the altitudes of Q, we know the altitude of R, we know the altitude of S. So it shouldn't be any great difficulty, okay? So note in the question, make sure you read everything before we start. The top step, PQ, has already been drawn for you. So it's already drawn up here, P1Q1, and is represented as P1Q1 in the section view. Okay, so we have all the information there we need now. Okay, so we're going to come back here to our drawing here now, and we're going to set this up. So P, the line PS is horizontal here, so we can just bring our point straight up. We can see here P and Q have already been done there. Okay, so P and Q there have already been fully completed there, and we know that they are at an altitude of 4.8 meters. So this is 4.8 meters. Okay, so we're going to bring up R here, and we're going to bring up point S as well. Okay, so we're going to bring up point R and bring up point S. Okay, so we know that P and Q are at an altitude of 4.8 meters, and we know that R is at 4 meters. Okay, so if we're setting this up in our profile view here, we know that's P and Q is at 4.8 meters, R is at 4 meters. So if we're scaling this, we know that R is going to be along this line here, and it's going to be 0.8 of a meter below Q. So it's going to be 0.8 of a meter here below Q. So 0.8 of a meter scaled down to our drawn is 8 millimeters. So if we scale that down to our drawn here, 0.8 of a meter is 8 millimeters there. Okay, so that point there now is point R. Okay, so point S here then is at 3 meters. So point S will be again another meter below point R, So point R is at 4 meters. Point S is at 3 meters, so it's going to be another meter. If we scale that down to our page again here, or to our map, it's going to be 10 millimeters below it. So we can just bring our line across here, and that point there is point S. So if we can draw these in here, and we can join that point R to point S. We know it's sloping base on the swimming pool, so that's point R to S done there. Okay, so that's point R down to point S there. Okay, so the next thing we need to look at then, okay, so that's point R to S. We have to put in our steps here. Okay, so we're going to have this is our top step, so we're going to go down 1, 2, 3. So there's going to be 4 different divisions here, guys. Okay, so we're 4.8 here. We have 4 steps to take. Okay, we're at 4 different divisions. R is at 4 meters. S here is at 3 meters. We don't really need this anyway, but I'm writing it in anyway. So there's a difference of 0.8 of a meter between here and between our level line here. So if we divide that up equally, we're going to have 0.2 of a meter between each step, and if we scale that down to our map here, that's going to be 2 millimeters between each step. Okay, so that's going to be 2 millimeters between each step. So they're quite quite close together when you actually scale them down. And if we just draw them in, first of all. Okay, and we can bring up our, from each point now on our step, then we can bring them, so we have point Q, so we'll bring these up and we can start drawing them in then. Okay, we have point R. So point R will be at 4 meters, then we're going to go up, over, up, over, up and over. Okay, so we can just draw them in. And that is the profile now completed through P to S. Okay, so that is our profile fully completed, as if we just cut down, sliced down through that with a big saw, and we've looked in at the edge of it here, and we have the profile there of the swimming pool there then. Okay, so that is the profile of it there. That's the last part of the question, and that is the complete solution to that question.